Welcome to lesson 9. Today we'll be doing simple and compound interest. I hope you find this topic interesting. Hope you get it. So Einstein is reported to have said, compound interest is the eighth wonder of the world. He who understands it earns it, and he who doesn't pays it. And the thing is, it's well worth understanding compound interest because you'll be dealing with it in your life, regardless of whether you want to or you don't want to. And it's worth understanding what you're getting into, because otherwise, like Einstein said, you'll be paying compound interest, which is really, really bad on so many levels. And superannuation is where you'll be earning it, and that's compulsory in Australia. So as soon as you get a job, your employer will be giving 9.5% of whatever you earn without asking you. Like, it's the law. The employer has to give 9.5% to your superannuation fund wherever you choose to do it, where you'll be earning compound interest, even if you don't invest in bonds and so on. Even if you choose to invest in shares and stocks and the stock market and so on. Like, in other words, if you want to avoid interest. The thing is, shares and stocks, they operate basically amounts to the same thing. You more or less earn on average something like 6, 7, 8% per year or something. Obviously, when the market goes down, you earn a loss. But regardless, on average, you earn like 7% a year or something like that. So you'll be dealing with that throughout your life. So you really should know, what it is and how it works and so on. And more importantly, I guess in some ways, well, I guess real life is more important. But if you're skeptical, the thing is, in 2-unit maths, this is in the syllabus more or less. And in fact, compound interest forms the basis of superannuation loan repayment type problems, which are some of the hardest that you will face in 2-unit maths, in my opinion. They're certainly one of the hardest. They're fairly hard questions. So if you don't understand compound interest, well, you're really going to struggle. Alright, so let's just do a quick revision of interest rates. Interest rates are assumed knowledge. Here's a really quick revision. If a sum of money, let's say P dollars, right? P stands for principal. If sum of money, let's call it P, is invested in a bank at an interest rate of R% per period for N periods. So R% per period. I've bolded and underlined the period because these two are related. You need to have these two matching. If you have the interest rate per year and this in months, that's not going to work. You need to convert it. You need to change that, and we'll get to that. And we'll get to this in a bit more detail in a bit. Anyway, so simple interest. The formula is simple. I is equal to PRA. The interest earned is equal to the sum of money you've invested multiplied by the interest rate, multiplied by how long you're investing it for. Easy. Compound interest is slightly more complicated, I guess. A stands for the amount that the money will have grown to. So it's not interest, right? This is really important to understand, right? The simple interest formula gives only the interest earned, whereas the compound interest formula gives principal plus interest earned. So you need to understand this. Anyway, so compound interest is A, the interest you've earned plus however much you started with, right, is equal to the money that you started investing with, the money you started with, multiplied by 1 plus R. Now, R is the interest rate. Same as over here, it's the interest rate. So this will be like 6% or whatever. That'll be 0.06. So 1 plus 0.06, which becomes 1.06. And it's important that you don't forget the 1. You need to have the 1. And then this is as a power, right? So this to the power of the number of time periods. So keep in mind that you need to have the matching periods. So if that's in years, this needs to be in years and so on. And we'll get to that in a bit more detail. Alright, so one thing I'd like you to really note is the difference between these two. This gives the interest only, does not include the money you started with. If you want to know how much your money will have grown to, then you need to do I plus P at the end, right? Whereas over here, you don't need to do A plus P because A has P included already. Typically, the question for this will be like, how much interest was earned? In which case, you will do P minus A. Or sorry, you'll do A minus P. The money that's total it's grown to minus however much you started with. Whereas over here, the question they'll ask is, how much will it has grown to? Like so they really will test basically whether you understand this or not. Okay, and this separates the people who just blindly apply a formula from the students who really understand what they're doing. So it's very frequently examined. And please don't take this topic lightly. The two topics we do directly after this, like I've mentioned before, superannuation and time repayments, they have some of the hardest questions you will come across in 2-minute maths. And these are the fundamentals, I guess. Alright, so let's just do some example questions. Find the simple interest incurred in $4,000 borrowed at 6% per annum for 5 years, hence find total amount payable. Preliminary step, the first thing you do, first thing you have to look at is the interest rate and the years, are they matching? 6% per annum per year, and that's in years? Good. I can proceed with the question. I don't need to do anything. I don't need to convert anything, okay? So let's proceed. Interest rate is 4,000, so I is equal to PRN. P is 4,000, outside of 4,000. Interest rate is 6%, multiply 5 years. Sub it in, get it. Now the question is saying, hence find the total amount payable. It's not asking you only for the interest. So the total amount payable means the interest and the money that you borrowed, right? So I plus P, interest plus principal. 4,000 plus 1,200 is 5,200. This is what I meant. You really need to understand what the question is asking and what the formula actually gives you. Alright, moving on to question 2. Find the simple interest incurred on a loan of $1,200 at 9% per annum over 30 months. Hence find total amount payable. Preliminary step. Always do the preliminary step. We look at this. 9% per year for 30 months. This is different. Right? That's in months. That's in years. So, alarm bells should be ringing all of you as soon as you read this. As soon as you see a finance type question in the 300 maths exam, the first thing you should, as soon as when you're reading the question, make a note. Just underline, highlight, do whatever you need to do. This is so important, right? That's given in years, that's given in months. We have an issue, we need to convert it. So we're going to convert this to years. As a general rule, you want to convert the time period to the interest rate in simple interest, right? In compound interest, we convert to the compounding period. We convert both of these to the compounding period. For example, if the question was in a compound interest question, right? If it was $1,200 borrowed, we borrowed $1,200 at 9% per year over 30 months, compounding twice a year. In other words, compounding every 6 months. So we need to convert this into every 6 months, or divide this by 6. Because it's going to compound every 6 months. So there will be 5 time periods, more or less, right? And this, it's per year. I need to get 6 months, so I'm going to divide it by 2. Instead of per year, it'll be per 6 months, so 4.5%. So like 4.5% per 6 months over 5 time periods, compounding 6 months, every 6 months. So I hope you get the idea. We need to convert. It's just really crucial. And the reason I'm stressing this so much is students make this mistake so often. It's just silly. Honestly, just pay attention to this. The rest of it is fairly easy. It's just substitution and so on, right? Time period is given in months. Interest applying per year. We need to convert n to years. And it's 30 over 12, which is 2.5. So 2.5 years. Alright, so I is equal to PRN. Sub it in. Simplify it. Again, the question was asking total amount payable. So again, I don't need to find just the interest. I need to find total amount payable. So I plus P, which gives us that, and that is the final answer. Easy. All right, now this is a fairly typical 2-unit problem. If this ever comes up in your HSC exam or trial exam, the question might look something like this. Well, you're not in year 7, year 8 anymore. They're not going to ask you these type of questions. Well, they may, obviously, they can ask anything, right? But more than likely, they'll ask you something slightly more involved, slightly more complicated. So find the difference between the simple interest and compound interest earned on $8,000 invested at 12% per annum for 7 years to the nearest cent. First thing we do, anytime we read a question, check the interest rate is per year, and that is per year. That's good. I don't need to convert anything. Alright, let's get started. So I need to find the difference between simple interest and compound interest earned on $8,000 invested. Now the total amount it's grown to, I'm only worried about the interest itself. So simple interest, I is equal to PRN, that's just going to give me one value. The compound interest is going to give me A, which is interest plus principal. So I'll need to subtract it. Just keep that in mind. Alright, let's get started. So P is equal to 8,000. Let's just note down the variables as we do in series and sequences. We always start off by noting down the variables. Alright, and I is equal to PRN. So this is a check, obviously. Yes, both are expressed in years. I have to check this first. We've already done that. Good. Let's calculate simple interest one first. I is equal to PRN. Straightforward calculation. 6,720. Now let's calculate the interest earned if you used compound interest. Okay, A is equal to P, 1 plus R to the N. Or I is equal to PR to the N. You can write it like this. Just keep that in mind. That is 1 point. That is 1 plus R. Just to be safe, I should probably write 1 plus R like I've done over here. 12%. Anytime we see a percent, do not use the percent sign of your calculator. I repeat, you are not to use the percent sign of your calculator. Again, this is another one of those silly mistakes students make. The percent button on your calculator works really weird. I've never liked it. It's very confusing and it only works in some situations. It's far better. This is just as easy. Anytime you see a percent sign, wipe off the percent sign, right? Wipe it off and put over 100. This always works. And just put this as a fraction. Put it as a fraction into your calculator and you can't go wrong, honestly. Anytime you see a percent sign, it could be 0.07%, whatever. I don't care what it is. Just wipe off the percent sign, put it over 100. You don't need to do anything else. Don't have to worry about, decimal points, nothing. Just do this and it'll always work. Alright, so I is equal to, so it's P plus 1 plus the interest rate to the power of number of years. Put on the calculator, you get that. But we're not done yet because that's not the interest earned. That is the amount that the sum has grown to. So $8,000 has grown to $17,600, whatever. Okay, so we need to compare the interest earned only, right? That's the only thing. So we need to subtract 8,000 from this. So we subtract 8,000 from this, we get that. That is the compound interest earned versus the simple interest earned over there. And the difference between the two is 2,965.45. Alright, so question 1 continued. What would be the equivalent simple interest rate to earn this compound interest in the same principal over the same time? So what would be the equivalent simple interest rate? So what are we missing? What variable are we missing? We're missing the interest rate. We're missing R. We should have everything else, right? So we have R. Let's rearrange the simple interest formula to make R the subject. You can do this at the end. I like to do it at the start. It makes it easy. Interest divided by PN. So we know what interest we need to make. We need to make the same interest the compound interest is making, right? So you sub that in. 9,685.45. What was the principal? Started at 8,000. How many years? 7 years. So we know we've got I, P, and N. Sub it in. And just convert it back to an interest rate and you get this. So you would need to have a simple interest rate of 17.30% to get the same amount as compound interest at 8% for this particular question. Not for every question, only this particular question. In this question, right? Alright, so question 2. To what sum will $1,000 grow to if this $1,000 is invested for 2 years at a rate of 18% per annum with the interest being compounded monthly? Okay, preliminary step as always. When we're reading a question, the first thing we look for is, are they all in the same time periods? So we have invested for 2 years, that's in years. 18% per annum, that is also in years. Compounded monthly, we have a problem. So, like I said earlier, in compound interest questions, we need to match this. It's compounding monthly, and to convert this to months. It's going to be 24, right? 18% per annum per year. Divide this by 12, should be 1.5% per month. Okay, so let's figure PRN. P is 1,000. R is 18% compounded monthly, and it's 2 years. Do R and N match the compounding period? No, they do not. We need to convert them. So R is 1.5% per month. And N is 24 months, And now we can proceed with the question. Revised variables, we change the variables. P is that, R is 1.5%, N is 24. Remember 1.5, wipe this off, put it over 100 before we put it in the calculator. Alright, so A, the rest of it is fair, it's just substitution. P is 1,000, 1 plus R, 1.5%. Remember 1.5 over 100, 1.5 over 100. We do not use 1.5, we don't use the percent symbol in our calculator. We always just convert it into a fraction. Easy. Right, so the power of 24 months, blah, blah, blah. Yeah, there we go. $1,000 will grow to become around 1,429.50 if invested for 2 years at a rate of 18% per annum, compounded monthly. Alright, so what sum of money would need to be invested now to accumulate $10,000 in 20 years at 8% per annum compound interest? Clearly we need to find P, what sum of money that we need to invest now. So P you can think of as present value. We have the present value. A is future value. Right? A is equal to P 1 plus R to the n, the compound interest formula, right? Another way to think of it is future value is equal to present value, open bracket, 1 plus the interest rate, close bracket, to the power of the time periods, I guess. Alright, so we need to find P. We've got A. We know what it's going to grow to. It's going to accumulate to $10,000. Now we can sum in the numbers now and then rearrange the formula to make P the subject and then sub in the numbers. Doesn't matter which, it doesn't really make a difference which one you use, but let's just rearrange the formula because it's just good algebra practice. We need to find P. We've got A, that's 10,000. The interest rate, oh by the way, we forgot to do the preliminary step. 20 years per year, yep, all good. We don't need to do anything. Alright, so R is 8 over 100, N is 20. We know A is going to be 10,000. The only thing we're missing is P. Let's rearrange, and you get that. Just divide both sides by 1 plus R to the n. This whole thing moves to the left, so to speak. So A divided by 1 plus R to the n. That's what P is. So I'm just going to sub in the values now. Sub them in, put them in a calculator, and you get the answer. So we need to invest $2,145.48 now in order for compound interest to apply, and so that we have $10,000 in 20 years time. Alright, question 4. In how many years will a sum of money double itself at 9% per annum compound interest? Alright, so this is slightly tricky. Let's just start by finding our values. And the preliminary step per year, yeah, there's nothing indicating there we need to change anything. Let's just get started. So we need variables. A is equal to P R to the n. Now, how much is it going to grow to? P is going to be P, obviously, right? R is 9% per annum, and N is what we need to find, the number of years. The thing is, what will A be? That's the trick of this question. Well, A is going to be 2P, isn't it? Because it has to double itself. So whatever you start with, and you start with P, remember, and then you have to have double that. So 2P, A is 2P. That's the only real trick of this question. So if we make the formula, right, A is equal to P, 1 plus R to the n. A is 2P. 2P is equal to P, 1.09 to the n. Divide out the P's, you get that, and that is just a logs question. Take a log of both sides, n comes down, divide this over there, put it in the calculator, and you get the answer. So any sum will double itself in around 8.04 years if invested at a compound rate of 9% per annum, which is kind of scary. Let's say you had $1 million, right? For example, if you had $1 million and you're getting compound interest rate of 9%, which is actually like stocks and shares give around 8% on average over the long term. So 9% isn't that far off. You might get 8-9% or so, right? Let's say you invested $1 million. In 8 years, you will have $2 million. That's pretty scary. I don't know about you, but that's over $100,000 a year earned doing absolutely nothing. So that's what they say. Money breeds money, right? When you have money, you get more money easier. So that's how rich people stay rich, I guess, right? Because they've already got money, they've got it invested, and they're just getting even more money because they already have money. Anyway, we're getting off topic. Let's just stick to the questions. At what rate does $9,000 need to be invested at in order to grow to be $13,000? in 5 years. So preliminary step, 13,000 5 years. Yeah, there's nothing. I don't see anything to be worried about. We don't need to convert anything. That's not that type of question. Anyway, we always check. Okay, let's just get started. So let's just find out our values, right? P, we know it's going to start to be 9,000. We know A is going to be 13,000. It has to grow to that. And we know the numbers. We know the time period. What we're really missing is at what rate. We're missing R. We're missing R. Alright, so that's the formula. Sub in the values. And we have the R's over there. Let's simplify as best as we can. 9,000 goes over there. 13 over 9. That the zeros cancel out. So 13 over 9 is equal to that. Let's take the fifth root of the left hand side and the right hand side. Take the fifth root. Probably you can do this on the calculator fairly easily. Subtract 1. Once you've taken it, subtract 1 and you get the R. Convert this to a percentage, you get 7.63%. Alright, so next question. You should invest $46,000, $792 for 30 years at a rate of 8.6% per annum compounding monthly calculator. So this is a typical exam question, right? Preliminary step. This is in years. This is in years. This is monthly. We have an issue. We need to convert. These. We need to convert this and this to months. So how many months in this? 30 times 12 will give us how many months there are. 8.6% per year. We need to divide this by 12 to get the monthly rate. Alright, so preliminary step. Convert everything. 360 divide blah 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 43 over 6,000. Alright, so we've done the preliminary step, we've converted it, everything's matching now. Let's apply the formula. A, 1 plus R to the N. We have $46,792, 1 plus R, we converted it, became 43 over 6,000, right? To the power of 360. Put in the calculator, you get the answer. Second part, interest accumulated during this period. What is the interest? Remember, in compound interest questions, this is what I was saying. They examine a lot in exams, and this is an exam style question. So interest is amount it grows to minus what you started with in compound interest type problems. In simple interest, the formula gives you the interest only. In compound interest, you don't get the interest only, you get the total value. Interest plus whatever you started with. Okay, so we need to subtract whatever we started with, and you'll get that, I guess. Alright, so simple substitution. We ended up with this much. Take away how much we started with, and you get that much interest earned. That is a crazy amount. You started with $46,000, you got interest of $565,000. So that's why I understand what I'm saying. People who understand it earn it. People who don't understand compound interest pay it, right? And if you had borrowed this much, you'd be paying this much. Right? Just think about that. People take home loans for, $700,000, $800,000. They pay back over 20, 30 years. So they borrow $800,000 and they probably pay back something like $3 or $4 million, which is insane. It's nuts. Anyway, we're getting off topic again. That wasn't easy. Alright, let's do number C, or letter C. The equivalent simple interest rate per annum. We know it's going to be crazy. Let's just do it anyway. So interest rate. Make that the variable and make that the subject. Interest has to be that much. Principal, how much you started is 46,000. Number of years, 360. So this is per month. Remember, we need to convert it to per year and convert it back to percent. 40% interest rate per annum, which is insane. Which is an insane interest rate. Anyway, that's it for today. So do the homework sheet, and best of luck with it.